Welcome to the third video in this series. In this video, I will show you the main steps to take when converting an Ethereum Solidity contract to a C# contract for the Neo N3 blockchain. This video series is meant to be watched in order. Before watching this video, please make sure you have watched all the earlier ones first. You will find a link to the playlist for this series in the video notes. Before we get started, here is an easy table to help you with your conversion efforts that you should memorize. It shows you the correct C# Neo N3 data type that you should use to replace the corresponding Ethereum Solidity data type. Replace any occurrences of the Solidity address type with the N3 uint160 type. Replace any occurrences of the Solidity bytes32 type with the N3 byte string type. And finally, replace any occurrences of the Solidity uint256 type with the N3 big integer type, except when it is used in a constant. When used in a constant, use the C# native integer type. N3 smart contracts do not have a pragma statement, so we just ignore it. In Solidity, you use the import statement to include external modules. In C#, you use the using statement. Most of the code in a C# smart contract is wrapped in a namespace. In this case, the namespace is neoband battles. This is done to partition the global namespace to help avoid collisions between duplicate names that exist between modules. Solidity and C# enums are almost identical, except in C#, the enums are declared with the public keyword. Here are the Solidity and C# declarations for the video platform's enum. In a Neo N3 smart contract, the majority of the code is contained in a top-level class. In this case, the name of that class is neoband battles contract. Above the class declaration, you will see several attributes that are required to properly build the smart contract manifest. These were discussed in the previous video. C# constant declarations have a slightly different syntax than Solidity constant declarations. Here you can see the invalid game ID constant in Solidity and C#. Also, in Solidity the type of the constant comes first, but in C# it comes second. In Solidity I use lowercase letters and underscores for constants, but in C# I use uppercase letters and underscores. Etherband battles do not emit any events. Neoband battles does. Here is how to create a Neo N3 event in C#. First, you declare a public delegate that describes the information the event will emit. As you can see, the delegate tells us that the payment made event will broadcast the ID of the game the payment was made for, the address that received the payment type, and amount. We use the naming convention of prefixing the delegate name with the word on and suffixing it with the word delegate. We end up with the delegate name on payment made delegate. Next, you define the event. All events must be preceded by a display name attribute that declares the name of the event. In this case, the event name is payment made. Now we declare the actual event. Note the use of the word public and static keywords before the event keyword. We use the naming convention of prefixing the event variable with the word on, giving us the variable name on payment made. We use our delegate name as the variable type, completing our event declaration. I convert Ethereum structs into C# classes. Here is the struct game details struct in Ethereum. It contains the fields that describes one game. Here is the class in C# that is its equivalent, named game details. The first thing to notice is the class constructor. The constructor performs some vital input parameter validation and then stores the parameter values into the object's data members. As you can see, each struct game details data member has been converted to a public C# class data member, with the appropriate type conversion replacement made for each data member. The uint256 ID field has become the big integer ID field. Note that the first letter of the C# field has the first letter capitalized as per the C# naming convention. You will find a link to the naming convention document in the video notes. The bytes32 request nonce field has been replaced with the byte string transaction ID field. NeoN3 does not use the proof of work consensus protocol, so there is no separate step for mining a transaction like there is in Ethereum. Instead, it is a single-step process, and because of that, there are no request nonces in NeoN3. The game state field has been ported across, requiring only the addition of the public keyword. The UN256 entry fee GUI field has become the big integer entry fee gas field, since NeoN3 payments are done with gas tokens, not GUI units. The UN256 band donation % field has become the big integer field of the same name. The address game creator address field has become the UINT160 field of the same name. The bytes32 game creator video ID field has become the byte string field of the same name. The video platform ID field of type enum video platform has been carried over. The UN256 numplayers field has become the big integer field of the same name. The UN256 game balance field has become the big integer game balance field. And the game payment summary field of the type struct game payments is now a field named summary of game payments, which is a class object of type game payment summary. Note that the game payment summary class declaration must be prefixed with the NeoBand Battles contract class name. This is because the game payment summary class is declared inside the NeoBand Battles contract class. And even though the game details and game payment summary classes are both declared in NeoBand Battles contract, you still need to use the prefix or you will get a compiler error. We can now start converting our functions. But first, a quick note about exceptions. Instead of throwing exceptions directly, I like to route all of them through a common function. This is the report error and throw utility function that I call whenever I want to throw an exception. As you can see, it outputs a log message using the runtime.log function. Then it throws the exception using the provided error message. This is handy when running a local blockchain instance in a console window because you can see easily any exception messages that occurred during the execution of your smart contract in the console window. There are certain validations that occur frequently in smart contract coding. It is a good idea to encapsulate them into utility functions. This makes your code more consistent and helps eliminate mistakes from repeating the same code in different places. For example, many of the functions you create will accept N3 addresses as input parameters. The way to test if an N3 address has not been initialized with a real address value is to compare it to the uint160.0 constant. The validateAddressNotEmpty function wraps that logic in a small utility function that returns true if the address has been initialized or false if not. In many cases, I like to create a sister function to a validation function like validateAddressNotEmpty that throws an exception if the validation fails. In many smart contract methods, you want to fail immediately and reject the transaction if the validation fails. To name this sister function, I use the naming convention of taking the first part of the validation function and adding the suffix or die to make it obvious what the validateAddress or die function does. C# does not have modifiers like Solidity does. You will need to convert your modifiers to ordinary functions and then call them where needed. Here is the Solidity modifier named only if valid game ID. It validates the given game ID as being valid through the use of a Solidity require call. If the game ID is not valid, it reverts the transaction. Here is the C# function named validateGameID or die. It does what the only if valid game ID modifier does. It calls the validateGameID function, and if that fails, it throws an exception. To quickly convert a Solidity require call to a C# if statement, invert the logic of the first parameter to the require call, and then throw an exception in the body of the if statement if that error condition is met. For example, the require call enforces the condition that the game ID is greater than 0. In contrast, the C# if statement checks to see if 0 is less than or equal to the game ID, and if so, throws an exception because that is an error condition. Here is a detailed example of how to convert a Solidity function to a NeoN3 function in C#. For this part, I'm going to show you step by step how I do this myself so you can see my workflow. The hash pending payment details Solidity function hashes a pending payment details struct to create a key that is used to store a pending payment details struct into a mapping. Here is how I would convert that function into a C# function. In C#, the key created by that function will be used to store a pending payment details object into the storage map that contains those objects. Storage maps, the Neo-N3 equivalent of Solidity mappings, were covered in the previous video. You will find a link to the relevant part of that video in this video's video notes. First, I copy and paste the Solidity function without the comments from the Solidity contract into the Neo-Band Battles contract. Then I remove any instances of the Solidity memory and view keywords since they are not used in Neo-N3 smart contracts. I move any modifiers in the Solidity code into comments at the top of the body of the new function. This reminds me which replacement functions I need to call to perform the validations those modifiers performed. Next, I note the function's scope, which is private in this case. If a returns attribute exists, I note the data type that it specifies, which in this case is bytes 32. I remove the scope and returns attributes. I replace the function keyword with the C# keywords that express the scope and return type previously noted. Since the Solidity function returns a bytes 32 value, and its scope is private, I replace the function keyword with the keywords private static byte string as per our data type replacement table shown earlier. I capitalize the first letter of the function name as per the C# naming convention for functions. I replace the struct pending payment details input parameter with its C# equivalent, which is a class object of type pending payment details. Then I use the Visual Studio Code rename feature to remove the leading underscores from input parameter names. Using the rename feature eliminates any errors that might arise from doing the substitution manually myself. Note, I like to add the suffix obj to parameter and variable names that contain class object references. I replace the keccak256 statement that hashes the Solidity struct with the C# equivalent that hashes the pending payment details object. This statement shows you how to hash a C# class object into a SHA-256 value, so you can use that value as a key to a storage map. You first serialize the object before passing that string to the crypto module SHA-256 method. Now I replace the modifier in the comment with a call to the validation function I created as a replacement for it. In this case, only if a valid game ID becomes validate game ID or die. I also fixed the game ID field name since it is different with the C# pending payment details object. Finally, I position the cursor on a blank line just above the hash pending payment details function so I can show you Visual Studio Code's common template for functions. I type 3 slashes in a row to activate it. As you can see, the IDE inserts some scaffolding for the comments that saves me the tedium of typing it myself. By waiting to do this step until after the function is defined, all the input parameters to the function are in the scaffolding so I don't have to type them myself. I'll fill in some helpful comments now. And we are done. I'm going to take a moment to tell you about templated strings. Templated strings make it easy to embed variables into strings in C# so that you don't have to concatenate many little strings together. Here is the hash pending payment details function again. As you can see, I have added an if statement that will call report error and throw if the pending payment details object passed to us is null. The $sign right before the opening quote of the error message tells the C# compiler that this is a templated string. Embedding variables in templated strings is easy. Just wrap the variable that you want to embed in curly braces. I like embedding the name of the function that threw an exception in my error messages. I could have just put the function name directly into the error message as part of the literal string, but instead I used the name of operator and then wrapped that operator in curly braces. This tells the C# compiler to evaluate the name of expression and to include its output in the resulting string. Why did I use the name of operator instead of just embedding the function name directly as a literal string? I'll show you. I'm going to rename the function temporarily to hash pending payment details deluxe. As you can see, the function name in the name of operator was automatically updated. Had I used a string literal, I would have had to remember to do the rename myself. And if I forgot to do that, the error message would now have the wrong function name. Join our free mailing list to be notified when the first interactive labs for the video series becomes available. Use the link found below in the video notes or visit neobandbattles.com. Neo.